There are two ways to name alkenes. As we did in alkanes, there's a common name and there's an IUPAC name. Normally, common is used for small alkenes, like 2 carbons in there, 3 carbons. We also can name them as common. But common is not used for larger alkenes. So if you have a big alkene chain in there with 5 carbons or more, we prefer that we name it in IUPAC rather than in common. So the simplest type of alkene is an alkene which is made up of 2 carbons in there. Okay, and the formula for the alkene, as we already explained, it's CmH2n. Okay, so here the formula for this one is C2H4. And the DBE for this simple alkene is equal to 1. So the DBE of this one is equal to 1. Why it's equal to 1? Because there is one double bond in there. So to name this alkene, simply what you need to do is drop the A and E of the alkane and replace it by E and E of alkene. Because always alkenes, they end up in E and E. Okay, alkanes end up in A and E, alkenes end up in E and E. So this one is 2 carbons. So instead of being ethane, it's going to, instead of being an ethane, all what you need to do is simply drop the A and E and replace it by E and E. So the name over here is going to be ethene. This is an IUPAC name. So whatever I named right now is called an IUPAC name. And which is the most used type of name, which is the IUPAC name. Now the common name, normally common, they don't have any specific rule in there. So you have to take it as is. So for the common name of ethene, this is called ethylene. To draw the condensed formula for ethene, all what you need to do is simply remove the single bonds. You can also remove the double bond, by the way. So always to draw the formula, as we said, all what you need to do is start from the left. So always start reading the molecule from the left. We're not naming here, we're drawing the molecule. So that is going to be a CH2. And then you have a double bond, and then you have another CH2 in here. And this is called a condensed formula. We can go fully condensed and remove the double bond in there. And if we do, then the formula will look like this. It's a CH2, CH2 in there. So if I draw a CH2, CH2, this means that every carbon needs to have 4 bonds. So definitely in between, there is a double bond. You can never start a structure with a CH2 unless that carbon is one of the carbons of the double bond. Now, if I want to draw the skeletal for the ethene, it's a simple double bond like this. So that is a skeletal with a carbon over here and a carbon over there. You don't have to highlight these carbons, but this is going to be the skeletal of ethene. Okay, now let's go ahead and look at a larger alkene molecule. So for a larger alkene molecule, we prefer that you follow the IUPAC rules over here. So below are simply the IUPAC rules for a nomenclature of alkenes. And the IUPAC rule says that you would need to choose the longest carbon chain that includes the degree of unsaturation, which means includes the double bond in there. And you have to give the double bond the lowest number. So I'm going to start by highlighting my longest carbonate chain that includes the alkene. And we need to give the alkene the lowest number. So to give the alkene the lowest number, that will force us to number the alkene from this side over here. So that is going to be 1, 2, 3, 4, and 5. Okay, so that is a 5-carbonate chain. So if I want to provide the IUPAC name for this one, a 5-carbonate chain is simply a pentane, right? So all what you need to do is drop the A and E and put an E and E in there. And when the double bond is at carbon number 1, we don't say 1-pentene. So we drop the 1 and the name is a simple pentene. So please put this as a note. So 1-pentene is wrong. The name is going to be a simple pentene. So this means that the double bond is immediately on carbon number 1. I look at pentene, I see that the ending is E and E. I have no number over here that tells me where the double bond is, so I'm just going to assume that the double bond is on carbon number 1. Putting 1-pentene is wrong. So make sure whenever you have one double bond and the double bond is at the end of the chain, make sure to give it number 1, the lowest number, and drop the 1 in the naming. Okay, let's have another example over here. So the rule again says choose the longest carbon chain that has the double bond in it. And if there are more than one double bonds, you're going to choose the longest carbon chain with all the double bonds. Make sure that you include them all. So over here, my longest carbon chain, I can go either this way or I can go this way. It doesn't matter, both are right, and they are going to give me the same number of carbon chain in there. So just to choose one way to go with, I'm just going to go ahead and choose that. And the rule says you would need to give the double bond the lowest number possible. So if I start from here, then that is going to be 1, 2, 3, 4, 5, and 6. My double bond always is the first number of the double bond carbon. So here my double bond number is simply carbon number 3. Okay. If I start from the other side, I'm just going to give another number over here. If I start numbering from here, then that double bond is still carbon number 3. So which way should I go? Now I need to look at the substituents. Here I do have two substituents. I have a methyl here and a methyl there. Now I look at the substituents and to choose that out, that gives the substituents the lowest number. This means that I am forced to start numbering from this side over here. Okay? So my name over here is going to be 2 methyls. I do have 2 methyls. That's going to be a dimethyl. So I'm going to start by naming the substituents first. It's the same format as naming that we did in the alkane. You start naming the substituents first. I have 2 methyls in there on carbons 2 and 3. So that is going to be 2, 3. It's going to be a dimethyl. Okay, and then a dash. I am done from the substituents. Now I want to go ahead and name my parent chain, which is 6 carbons. It's a hexene. It's a hexene, but the double bond is not on carbon 1. So I have to exactly locate where my double bond is. My double bond is on carbon number 3. This is where my double bond is. It starts on carbon number 3. So that name is going to be 3. And it's going to be hexene. So that 3 that you see here is for the alkene. That tells me my double bond is not on carbon number 1, my double bond is on carbon number 3. Another way to write the name, and it's up to you to choose whatever method you like, I can simply include the number between the parent name and the ending. So it's going to be 2,3-dimethyl. That doesn't change. So the substituent name doesn't change, but I can do hex, and I can put the 3 between the hex, which is the parent name, and the ending of the name of the functional group, which is the alkene. Any of these methods is acceptable. Now, when you have more than one double bond, the rule says that your longest carbon chain has to include all the double bonds in there, even though it is less number than the bigger chain. If there is a possibility of a big carbon chain, It doesn't matter. You have to include all the double bonds in there. So go by the route where you choose all the double bonds and include them in one chain regarding the number of the chain. So here I have no option but going this way. And then when you number, make sure to give the first degree of unsaturation the lowest number, so that this double bond, you have to start numbering from here, because this double bond is closer to the end, so it's going to get the lowest number compared to this double bond over here. So that is going to be 1, 2, this is a 3, this is 4, 5, 6, 7, and 8. Now I have a chain of 8 carbons. I know that 8 carbons is octene. So what I'm going to do over here is I am going, since it is more than one double bond, what we're going to do here is we are going to simply keep the E and E, but I would need and introduce another letter in there, because there is a prefix that I have to introduce to indicate how many double bonds I have. I have 3 double bonds, so simply the ending has to be tri-ene in there. And the name doesn't look good if I do octetriene. So this is why I would need to introduce an A in there. So that A is introduced between the oct and the triene, so that I can pronounce it as an octa triene. Okay? So again, I have 3 double bonds, and I have to indicate how many double bonds I have. I have 3, so this is why I need to use the prefix tri. I'm going to keep the E and E at the end, but for the parent name, which is the oct in there, in order to combine it with the triene, I have to introduce a letter, which is the A. So A here is very important to separate between the oct and the triene, and again, the pronunciation will look better. I need to indicate where these double bonds are, so every double bond needs to have a number. And here in this case, I need to include number 1 in there, because I have more than one double bond. So it's and the chain is long, so I cannot skip number 1. So that is going to be 1, that's going to be 3, and that's going to be 5. Always you indicate the beginning of the double bond, and this is where the double bond starts. It starts at 1, at 3, and at 5. So the name is going to be 1, 3, 5. Put commas between the numbers as usual, and put a dash between the number and the letter. So now I am done with the whole parent name at the end. All I need is the substituents. I would arrange the substituents in alphabetical order. So I do have a butyl chain in here. Name it as usual, guys. So that is a butyl chain. And then I have a methyl chain over there, or a methyl group. So that is going to be a methyl group. You need to arrange those in alphabetical order. So on carbon number 4, I have my butyl. B comes before the M. So on carbon number 4, I have a butyl. And on carbon number 7, I have a methyl, and then a dash, and then 135 octa tri. Okay, this is another example over here. Again, your longest carbon chain has to include every single double bond, so that's it. I don't care about the rest. This is every single double bond, and I'm going to end up having a chain of 6 carbons. To start numbering, you need to give your priority. Your priority is the double bond. You give the double bond the lowest number, and then you look at the substituent and give them the lowest number. Here in this case, if I start numbering from the side, both my double bond and my substituents are going to get the lowest number. So here it is. It's a chain of 6 carbons. Cl, when it is there, that is called chloro. NO2, when it is a substituent, it is called nitro. Please know these, and you can have the table for them in the exam. And you are going to arrange those in alphabetical order. Of course, the C comes before the N. The name is going to be hexa. It's 2 double bonds. So I'm just going to go ahead and use the prefix di. in there to indicate that it is a diene. So it's going to be, the ending is going to be a hexadiene as we did before. So see that A that I introduced in there, this is a must to separate the hexa from the diene because the pronunciation will look better. And then I do have on the double bonds are on carbons. They start on carbons 2 and on carbon 4. So that is going to be 2,4 hexadiene. I am done with the parent name. Now for the substituent, I arranged them in alphabetical order. So I have 2-chloro, 4 nitro, and then 2,4 hexadiene. Now to name cycloalkenes, it's the same thing as we named, same rules as we named cycloalkanes, except the ending is going to be in the cycloalkene. This is the ending. So let's have over here a DBE calculation for these. So this one, the DBE for it is equal to, I have a double bond and I have a cycle. So I have a double bond, this is a dB of 1. I have a cycle, it's a dB of 1. So this one is a dB of 2. Okay. For this one here, the name is, it's a cycle. So, and this cycle is made up of, see how many carbons? 6 carbons in there. So this is 1, 2, 3, 4, 5, and 6. I am representing this in its skeletal form. So the name is going to be a cyclohexene. Cyclohexene. Now, as I said before, if the double bond is the only double bond in there, then definitely you are starting the numbering from that double bond. This is carbon number 1. It is carbon number 1. So we're going to drop the 1 in there. You don't do 1 cyclohexane. You just do cyclohexene. This is going to be the name. Because when I say cyclohexene, I'm going to draw the double bond anywhere. I can draw it like this here. This is still 1. And it is the same as drawing the double bond here, which is still 1. Because my rule says that I need to give the double bond the lowest number. So it's going to be 1 anyways. Or I can just put it over here. And I'm just going to still number this as 1. So all of these structures are going to be the same. Okay? So this is why whenever you have 1 double bond in there, no substituents, then you can go ahead and drop and say this is a cyclohexene without even putting a number 1 in there. Even when you have a 1 substituent and your double bond is on carbon number 1, you don't even have to say that this is 1 cyclohexene because we're going to assume directly that the double bond is on carbon number 1. You start putting numbers for the double bond in the cycle whenever you have more than 1 double bond. So let's have an example over here. I do have a double bond, so I'm going to give my double bond the lowest number. This is the priority double bond, the lowest number. So that is going to be a cyclohexene. So the ending is going to be a cyclohexene. Notice I didn't say 1 cyclohexene. I said cyclohexene. So immediately I'm assuming that the double bond is on carbon number 1. And then I do have my methyl. So now my methyl it's important that I would need to indicate where my methyl is, because my methyl, if I don't say that it is on carbon number 1, it can be anywhere on the cycle. So I have to indicate where my methyl is, and my methyl is on carbon number 1. So that is going to be 1-methyl cyclohexene. Guys, 1-methyl cyclohexene is one word. So I'm just going to bring it over here, and that is going to be 1-methyl cyclohexene. When you have, again, a 1 double bond, your ending is going to be in the cyclohexene. Okay, it's a hexene in there. So it's a cyclohexene. Here you go. And now we're going to give the substituents the lowest number possible. So I am going to start numbering from always start numbering from you don't have an option. You don't have an option. So if your substituents start from this side, you have to start numbering from the double bond. So that is going to be carbon number 1. And then here's the thing, it's very important. When you start numbering from one carbon of the double bond, you have to continue and number the next carbon of the double bond. So that is going to be 2. So I cannot number one carbon and then go this side and say this is 2. This is wrong. Because if you start numbering from the double bonds, these two carbons are connected with each other. And if they are connected with each other, I need to move along the carbon chain. This is 2, this is a 3, 4, 5, and 6 in there. I'm going to arrange my substituents in alphabetical order. So to arrange them in alphabetical order, I know that this guy is an ethyl group, and these two are methyl groups in there. Okay, so on carbons 3 and 4, I have a methyl, and then E comes first. On carbon number 1, I have an ethyl. So that's going to be 1 ethyl. On carbons 3 and 4, I do have a dimethyl. Please don't forget the prefix di, because every single substituent needs to have a number. I have 2 numbers, I need to have 2 substituents in there. So the di is important. If you forget it, this means that your name is not right. Another example, let me put another example here. So if you have, let's put a cycle of 5 membered rings now. So if I have something like this, and if I have a double bond, and now my propyl group is over here, okay, and then I do have a methyl group in there, then again, I'm going to start my numbering of the double bond. I need my double bond to get the lowest number possible. This is the rule, and then the substituents. Okay, so over here I have 2 options. I can start numbering the double bond from here, and if I do this, then this is going to be carbon number, this is going to be carbon number 1, this is going to be 2, that is going to be 3, and that is going to be 4, and that's going to be 5. Notice what I did. I moved in this direction there, because if I start numbering the double bond, the 1 carbon of the double bond, I need to finish and number the 2nd carbon of the double bond. I cannot go, as I said, 1, 2 like this. This is wrong. So I need to go this way over here, and that is going to give the methyl group. Let's name this groups in there. So this 1, 2, and 3. This is a propyl group. And this one here is a methyl group. So the methyl is going to be on carbon number 3. The propyl is going to be on carbon number 4. The M comes before the P. So M over here gets a lower number than the P. I can, if I number it from, let's say, from this side over here, from this carbon, then that is going to be 1, this is going to be 2, this is going to be 3, and that is going to be 4, and that is going to be 5. This is more carbons, more carbon numbers than the other route. So 4, 5 substituents is different than 3, 4 substituent. 3, 4 substituent is less number in the chain. So this is why I am not going to go with this route. I'm going to go with the other one, and I'm going to start my number from here. Okay, numbering from here, and that will give me the lowest number possible for these substituents. So the name is going to be, that is a cyclopentene. I don't have to do 1. This is a cyclopentene. And then on carbon number 3, just arrange in alphabetical order, I do have a methyl. And on carbon number 4, on carbon number 4, I do have a propyl. And then that is a cyclopentene. Please don't put a space between the propyl and the cyclopentene.